Hi, I'm Frederick. I'm lead 3D artist at Blindflug Studios, an indie game studio founded in Zurich, Switzerland in 2014. We've released games across all major platforms that are enjoyed by millions of players. With the help of archive material, animations, interviews and music clips, The Miraculous Transformation of the Working Class into Foreigners is a Swiss-Italian documentary that tells the story of migration from neighboring countries to Switzerland in an entertaining way. We at Blindflug Studios used the game engine Unreal Engine 5 to create animations for the movie using the latest virtual production tools. When Samir, an acclaimed director from Switzerland, approached us at the end of 2021, he was in need of a virtual double of his younger self to tell his story. With Epic having just released MetaHumans and new Unreal Engine features like improved real-time ray tracing, we now had tools available to realize his vision using real-time virtual production for achieving high-quality results. At that time, Samir got in touch. We were strictly a Unity company. But seeing the new Unreal features showed us that with our knowledge of creating 3D video games, we could easily switch the engine and use the new features of fully animated virtual production to bring Samir's vision to the screen. What's fully animated virtual production? Virtual production means producing movies in a virtual space in real time. For example, for The Mandalorian, instead of green screens, video walls showing digitally created environments were used for backgrounds. Fully animated virtual production is a workflow where tools for live action filmmaking and game production are used to create animations. Movies like Tintin or the remake of The Lion King use techniques like motion capture or using real cameras for recording their images. This enables directors to be able to work in an animation movie similar to how they work in a live action movie. They're able to direct the camera and actors and see results immediately. While years ago this cost millions to produce, the latest technological developments lowered the costs and requirements to make this available also for smaller indie productions. Why we used virtual production for working class? So the first reason for why we used virtual production was cost. It can be cheaper than traditional animation by using new technologies like MetaHumans and Quixel scans, as well as not having a need for time-consuming final renders. Additionally, by being a game engine, the tech is focused at and running on consumer machines. But there are additional important points as to why we used virtual production for creating the animations. It's quick and iterative and thus lets the director work on his vision and cut during the production process. Additionally, because it's created in a video game engine, we can also use the material used for the movie for a game or an interactive experience, which we did. Also, we can use our knowledge of working on video games and use talent from both animation and video game industries for these production. And this industry is going through extremely quick release timeframes of tools, which means we can do existing things better each year, and also we become able to do totally new things not possible before. Creating a project like this is multidisciplinary. Our main partner was Dschoint Ventschr, who produced and directed the movie. We worked closely with the director, Samir, who joined us at our office to direct the work on animation, which we updated with him live in the engine. For producing the animation, we coordinated and worked together with specialists in the fields of performance capture and 3D modeling. We worked with motion capture studio Quantum Stage using performance capturing actors to animate the MetaHumans. For special custom parts of the environment and class, 3D model production studio NXA was tasked with the production of 3D assets. Already for the initial concepting, we started with the most important part, creating versions of Samir in different ages. This was directly done in the MetaHuman editor, and then also in the editor in real time tweaked together with the director. Because of the high visual quality MetaHumans have in real time, these virtual humans we created in pre-production are essentially the characters we used throughout production, for visualization at the performance capture and in the final renders, having the same high visual quality through all steps. For video games, the technique of grayboxing describes using gray boxes for blocking out a level early in development. This is then used for iterating over gameplay long before the 3D art assets are ready for implementation. We used these techniques for the animatics, but were able to leverage metahumans and high-quality assets in addition to real-time lighting to provide higher developed visuals at an earlier stage. This results in getting quality feedback earlier, which we then could work on already at this stage of production. For the high-quality assets, we used various sources that we then put together in-engine. With the help of the nanite feature in Unreal Engine 5, we could now use assets having millions of polygons and thus a crazy amount of details without having any issues with performance. Since we use pre-produced assets, we were able to block out environments very quickly. For the few special assets that we didn't produce in-house or sourced from stores, we used outsourcing, which usually adds quite some additional coordination. Using the animatics and gray boxes, we already had a good idea of what will be seen of the needed assets. We used this knowledge when producing the asset briefs for our outsourcers. Examples for this are some of the claws for the characters, plus the environment of the first shot, where a highly detailed recreation of the Zurich main station from the mid-20th century is used. Part of the possibilities of animation was that we could use real-time effects which are not easily possible in live-action movies. We applied particle effects for things like snowfall, water and fire, which were then again visible during changes to the camera setup and for performance capture. For cloud animations, we used volumetric clouds, which again were visible in-engine, though this was admittedly not possible in real time since this kind of feature is very new and requires additional graphics resources. The sky and light are again changeable in real time, which allowed us to quickly change the light setup together with the director. Even when problems appear in post-production, these can usually be easily fixed. We got contacted just weeks before the premiere because the company doing the final touches to the production couldn't work with the light changes we employed in one scene. We sent the fixed animation on the same day that we got informed about the problem. Usually called motion capture, the addition of facial capture transformed the term into performance capture. It's capturing the full performance of the actor. We work together with Quantum Stage to provide the director with on-stage visuals of how the actors look like in the animation. This also allows for quickly changing camera angle as well as change the environment of the animation to better fit the performances. It can also immediately be reviewed with the camera angles defined from the animatics. With the raw data from the performance capture, it was possible to quickly render out updated variants of the animatics, now with the animations from the capture. This allowed us to see if something needs to be captured again, in addition to see if and where cleanup was needed. Edits for the animations can then be done directly in the engine, for example adjusting the direction of where the character looks, or hand positions on a table. In some cases we did facial animations directly in the engine, because characters didn't always need high quality captures from actors. Additionally, it's not always possible to capture a face, for example if the performance is a brawl, where the hardware of the facial capture is not practical because it's shifting from the action or even in danger of being damaged. We also use traditional 3D animation techniques right in the engine to animate the frog or the base of the clouds in the engine, which allowed us to stay in the engine and save time from configuration of and round tripping to other applications. Together with the director, we worked in-engine to edit the material. Changes in camera movement that would, for live-action movies, require additional hardware and personnel are easily done with the available tools. Using the editor, we could either cut the shots right in-engine or opt for recording longer patches and cutting in an external application. We choose to cut in the engine because this lowered the needed time for the whole animation, because it reduced the amount of needed performance capture cleanup, particle animations, and other things. Being a game studio, we also were able to use our knowledge of scripting to implement our own solution for some visual effects. For the moving text in 2 of the scenes, we implemented scripts to visualize the text along splines, which basically means that we were able to build a feature that does not yet exist in engine by using virtual scripting. One additional very important part of this production was that we used the production to also create the cinematic for a game that we created for the movie. This connects the app to the movie by using the same visuals. While being fully static for Arbeiterklasse, for a future production, this will allow us to produce a game and a movie or series with the same characters and environment at the same time. Something we're definitely looking forward to do.